Okay, welcome back everyone. So now let's look at just quickly on the history of AI. So one quick way to summarize the milestones in AI history is essentially to list the Turing Award winners over the years. But as you can see from this chart, we can say that the inception of artificial intelligence, the inception period was between 1943 and 1956. The first work that is now generally recognized as AI was done by uh, Warren and Walter Pitts in 1943. They drew on three sources: knowledge of the basic physiology and function of neurons in the brain, formal analysis of propositional logic, and Turing's theory of computation, and they proposed a model of artificial neurons in which each neuron is characterized as being on or off, with a switch to on occurring in response to stimulation by a sufficient number of neighboring neurons. Now, there were a number of other examples of early work that can also be considered as AI, including, for example, two checkers playing programs developed in 1952. However, Alan Turing's vision was the most influential, as he gave lectures on the topic as early as 1947 and really defined a specific agenda for developing artificial intelligence. As we saw, he introduced the Turing test, machine learning, genetic algorithms, and reinforcement learning. He also dealt with many of the objections that were raised at the time, as we will discuss later in this class. And he also claimed that it would be easier to create a human-level artificial intelligence by developing learning algorithms and then teaching the machine rather than by programming its intelligence by hand. So rather than defining set rules, we should focus on developing machine learning algorithms that allows the machine to learn by itself. Okay. The following period is from 1952 to 1969. This is a period of early enthusiasm and great expectations, where researchers focused on tasks that were considered reflective of intelligence in humans, including playing games, solving puzzles, solving mathematical problems, and taking IQ tests. So this period is named Lokma No Hands era, essentially, with focus on developing general problem solvers for a specific class of puzzles, for example, and things like that. Now, you can see here and in your textbook a discussion of the rest of the important steps. But what's more important really is to see where we stand today. What is the state of the art when it comes to artificial intelligence, what it can do and cannot do. So in 2018, Stanford University did a study on the current state of AI, and they concluded that significant increases in future use of AI applications will include more self-driving cars, healthcare diagnostics, targeted treatments, physical assistance for elder care, and so on. And they also said that society is now at a significant point in determining how to deploy AI-based technologies in ways that promote rather than hinder democratic values such as freedom, equality, and transparency. Now, when you look at significant milestone, you see, for example, in terms of publications, AI papers increased 20-fold between 2010 and 2019 to about 20,000 a year, with the most popular category of research is machine learning, followed by computer vision and natural language processing. The sentiment in general, about 70% of news articles on AI are neutral, but articles with positive tone increased from 12% to 30% by 2018. The most common issues that people raise when it comes to AI are ethical consideration like data privacy and bias of the algorithms. When you look by number of students, course enrollment increased 5-fold in the US, 16-fold internationally, with AI becoming the most popular specialization in computer science. Conferences attendance at NeurIPS, which is the flagship conference for artificial intelligence, increased 800% since 2012, and other conferences grew as well. In the industry, AI startups in the US increased 20-fold to over 800. International reach, China publishes more papers per year than the US, and about as many as all of Europe. But if you consider citation-based weights, then US authors are 50% ahead of Chinese authors. In computer vision, error rates for object detection improved to less than 2%, exceeding human performance. Accuracy on open-ended visual question answering improved from 55% to 68% by 2015, but still not at human level. Speed, training time for image recognition task dropped by 100. The amount of computing power, GPUs and so on, used in top AI application doubles every 3 to 4 months. In language, accuracy on question answering increased from 60 to 95 over a 4-year period. Compared to human benchmarks, by 2019, AI systems had met or exceeded human-level performance in many benchmarks like chess, Go, poker, Pac-Man, Jeopardy, ImageNet object detection, speech recognition, Chinese to English translation, games like Quake 3, Dota 2, and StarCraft 2, many Atari games, skin cancer detection, prostate cancer detection, protein folding, and diabetic diagnosis. All of these are areas where AI exceeds human performance. Now, how will future AI systems operate? No one really knows. Again, the field is constantly developing. There are some areas that are not well understood yet, and the future will probably reveal what models come next. So, what can AI do today? So, in robotic vehicles, of course, we've all heard of Waymo. which started in 2018 to test vehicles. And essentially by 2018 they had covered 10 million miles on public roads without any serious accident, with the human driver stepping in to take over only once every 6,000 miles. And the company now operates in many cities. If you've been to San Francisco or LA, for example, you can easily order a Waymo. In the air, autonomous fixed-wing drones have been providing cross-country blood deliveries in Rwanda since 2016. Quadcopters can perform aerobatic maneuvers, explore buildings, to construct 3D maps, and self-assemble even into autonomous formations. Another area is autonomous planning and scheduling. So, for example, NASA's Remote Agent Program became the first onboard autonomous planning program to control the scheduling of operations for spacecraft. During the Persian Gulf crisis of 1991, the US deployed dynamic analysis and replanning tool, which is essentially an automated logistics planning and scheduling for transportation that involved up to 50,000 vehicles, cargo and people at a time. Had to account for starting points, destinations, transport capacities, routes, and so on. Every day, companies like Uber, for example, and mapping services like Google Maps provide driving directions to millions of users, quickly plotting optimal routes, taking into account current and predicted future traffic conditions. So in machine translation, the online machine translation system now enables the reading of documents in over 100 languages. In speech recognition, in 2017, Microsoft showed that its conversational speech recognition system had an error rate of less than 5%, which matches human performance. In recommendations, companies like Amazon, Facebook, Netflix, YouTube, Walmart, and so on, of course, use machine learning to build recommender systems to propose products and services of interest to you. So the field of recommender system is changing rapidly due to new deep learning methods that analyze content as well as history and metadata. Game playing, image understanding, medicine, of course. So all of these are areas. For example, in medicine, AI algorithms now equal or exceed expert doctors at diagnosing many conditions, particularly when the diagnosis is based on images. That includes Alzheimer's disease, cancer, and skin disease, and others. So, as you can see, there are many fields where AI is used today, and the widespread adoption of AI is not limited to these fields. There are many other applications as well. So throughout this class, we will learn many of the models that are used in these applications, and you will get a chance to program and play around with them and look at the results. So it's a good time to be an AI right now. See you in class.